Let's talk about something that's already running in the background of your life, deciding what you watch, who you might date, and even if your loan gets approved. That's right, we're diving into machine learning. We're going to break down how computers are, well, literally learning to think for themselves without a human programmer telling them exactly what to do every step of the way.
Okay, to get this, let's start with something we've all been through. Just think back to learning how to ride a bike. Nobody handed you a manual on physics and balance, right? No, you got on, you wobbled, you probably fell a few times, but with every single attempt you made tiny adjustments, and eventually your brain just clicked. It figured it out from experience.
And that right there, that's the absolute core idea behind machine learning. It's not about a computer following a super detailed, rigid set of instructions. It's about it learning by doing, through trial, error, and a whole lot of data.
So, let's jump right into our first section. Learning without rules. We're about to find out how computers are starting to teach themselves.
So what is machine learning, really? Well, officially, it's a field of AI. But the key ingredient, the secret sauce, isn't code. It's data. Instead of feeding a computer a long list of commands, you feed it a massive amount of information and basically tell it, hey, figure out the patterns on your own.
This slide really breaks down the old way versus the new way. Over on the left, you've got traditional programming. Think of that like a super detailed recipe where a programmer has to write a rule for every single thing that could possibly happen. But on the right, you have machine learning. That's more like giving a master chef thousands of finished meals and letting them figure out the recipes on their own. Let's make this real with something you use every day, a spam filter. The old way was to make rules, like if an email has the word lottery, it's probably spam. But the machine learning way? You just show the computer 100,000 emails. Tell it which ones are spam and which aren't, and let it go to work. The machine analyzes everything, the words, who sent it, the sentence structure, to build its own understanding of what spam looks like. And here's the really powerful part. It gets smarter with every single email it sees. Okay, so now that we know what it is, let's get into the how. It turns out machines have three main ways of learning. Let's break down these methods: supervised, unsupervised, and reinforcement learning.
First up, we have supervised learning. And if you remember just one word for this one, make it labeled. In this method, you're giving the computer a data set where all the correct answers are already there.
You know, the easiest way to think about this is like learning in a classroom with a really good teacher. The labeled data is like your textbook, and it comes with an answer key in the back. The computer just studies the examples and the right answers over and over until it learns the underlying patterns.
So the crucial thing here is that the computer is trained on data that's already been neatly sorted for it. For instance, you show it thousands of pictures that are explicitly labeled cat and thousands labeled dog. By studying all these examples, it learns the visual clues for each, so that eventually it can look at a brand new picture it's never seen before and say, yep, that's a cat.
Next, we've got unsupervised learning, which is pretty much the total opposite. Here, you give the computer a massive, messy pile of data. But this time, there are no labels, no answer key. The machine's job is to make sense of the chaos and find the hidden structures all by itself.
It's kind of like handing a kid a giant box of random building blocks. Without any instructions, what do? They naturally start grouping them, right? Maybe by color, or by shape, or by size. They're discovering the patterns on their own. And that is exactly what an unsupervised algorithm does.
This method is incredibly powerful because it can find connections that we humans might never, ever see. And the most famous use case? E-commerce recommendation engines. They analyze the buying habits of millions of people, discover that, hey, people who buy this coffee maker also tend to buy these coffee filters. And then, boom, they generate those you might also like suggestions.
Our third and final type is reinforcement learning. And this one is all about learning from consequences. A computer program, which we call an agent, tries to achieve a goal. When it makes a move that gets it closer to that goal, it gets a little reward. When it makes a bad move, it gets a penalty. Honestly, the analogy here is perfect. It is exactly like training a dog. You tell it to sit, it sits, you give it a treat. That's the positive reward. It barks or runs away, no treat. Over time, the dog figures out that the action sit is the best way to get the most treats.
And this is exactly how some of the most advanced AIs learn to do incredibly complex things. Think about Google's famous AlphaGo program. It wasn't taught the rules of the game Go by a person. Nope, it just played against itself millions and millions of times, rewarding itself for moves that led to a win, until it developed strategies so advanced it became better than any human player in history.
Okay, so we've covered the theory,
Now for the really fun part. Let's see how machine learning is being used right now, out in the real world, in industries from high finance all the way to a family farm.
So we've got the how, but what about the what? I mean, after all this talk about cats, dogs, and board games, what is the real practical impact of machine learning on our daily lives?
Well, in the world of business, it is everywhere. Banks use it to look at past loan applications to decide if you're a safe bet. Insurance companies use it to predict who's most likely to file a claim. And of course, every single major online store uses it to predict what you'll want to buy next.
But the impact goes so much deeper than just what we buy. We're now talking about using this technology to tackle some of humanity's biggest problems. This isn't just about making things more efficient. This could literally help us feed 1 billion more people. Just take farming in India, for example. Machine learning models can now predict crop yields with incredible accuracy. A farmer can just take a photo of a leaf on their phone, and an AI can tell them if it has a disease. It's even being used to optimize irrigation, saving one of our most precious resources, water.
And this brings us to our final and maybe our most important section. We've seen what machine learning is and what it can do, but let's talk about why this is such a critical thing for you to understand for your own career.
This quote really just says it all. You don't have to be a math PhD to get in on this revolution. In today's world, the real value comes from understanding what these tools can do and knowing how to ask the right questions of your data. That skill alone is worth its weight in gold.
So, if you take one thing away from all of this, let it be this. Machine learning isn't some kind of magic. It's a powerful tool built on data and algorithms that any smart professional can learn to use. So the only question left is, what problem are you going to solve with it?